In this video, I'm going to do a proof. So, prove that if n is an even integer, I'm sorry, I know where I got even. If n is an integer, perfect. And 7n minus 3 is odd, then n is even. So how do you even do this? I mean, you're looking at this. Now, firstly, before you do this, you need to know what proof you're using. We got direct proofs, proof by contrapositive, and yeah, so basically we got a lot of proofs, right? So now we need to understand what we're dealing with here. So we need to tell ourselves that, okay, ourselves or yourself, how are we going to do this, right? We have to prove that if n is an integer and 7 minus 3 is odd, then n is even. So if you make 7n minus 3, I'm sorry, we don't need to make 7, they're telling you this is odd. Then how can we show this one element is even? It doesn't make sense, right? I mean, why are we doing this to ourselves? Why are we killing ourselves before we can die? Sure. We're using proof by contrapositive over here. Because if we say, prove that n is odd, then n is an even number. So this is what I'm saying, right? Let's say n is an integer, is p. Then n is even, that's q. Now, p implies q. To write the contrapositive, it's not p implies not q. And I'm sorry once again, because it's not q implies not p. So not q implies not p. So what that means, you take the opposite of that over here first. So you write your proof down, right? So proof. So assume n is odd. Then now, if n is odd, right, how will it be represented? Always, if it's even, it's like, can be represented as any number equal to 2k. Or if it's odd, it'll be n is equal to 2k. Now, whenever you write n is equal to 2k, it's odd. Yeah, 2k plus 1. You're doing the opposite, right? You have to say k, whatever symbol you introduce, is an element of integers, right? You have to, because it's telling you you're dealing with integers. Okay? So now that we got 2k plus 1, we just have to put it in this equation and prove that it's even. Remember, we're doing the opposites. So now, to prove this, we just, which implies 7. And because we said let n be 2k plus 1, that's what we're going to do. We're going to be let n equals 2k plus 1. Now, if you work this out, that is 14k plus 7 minus 3. Work this out, that's 14k plus 7 minus 3, 654 plus 4. And then, I'm going to prove that it's even, right? So, if I take a 2 as a common factor, because 2 times any number is even, then I get 7k plus 2. And as you can see, 2 times the number has to be even. Now, when you come to this step, you want to basically represent the brackets as any symbol. So, I'm going to do m. Why not? So, 2m. Every time I told you introduce a symbol, you have to say m is an element of z. Now, do not write in brackets. I'm using in short form, but you can say where m is an element of integers. Right? Now, okay, also you have to write m is equals to 7k plus 2, because this 2m is this. So m is equals to 2k plus 2, and then you write m is an element of integers. So that's how you prove it, right? So we did the contrapositive. We said that if n is odd, then n is an integer and 7 minus 3 is even. So we took p and put it in the first statement. So we took this statement, put it in the first line, took this statement, put it in the last line, and then we did the opposite of both the statements. So that's how you do a proof using proof by contrapositive.